Okay, example 1. Shh. Guys, I don't want to have to yell. Solve x squared plus 3x minus 4 equals 0. Okay, there's two things today that we are not used to seeing. Normally, we don't see the word solve right here. We see the word factor. But the reason that we see the word solve today is because it's set equal to 0. And normally it hadn't been set equal to 0 to this point, but today it is. So the first thing that you have to do is factor it. And this is a quadratic trinomial with a leading coefficient of 1. So we're going to factor it by looking for two numbers that add up to 3 and multiply to negative 4. Okay, positive 4 and negative 1 will do it. Okay, now, had this problem just said factor, we would be done. However, it doesn't just say that. It says solve, and that's because it's set equal to 0. What that means is you have to continue in the process until you have the x's by themselves. Basically, that's what happens. So we're going to set x plus 4 equal to 0, and we're going to set x minus 1 equal to 0. And then from there, it's simple. To solve for this x, what do we do? Correct. And so your first solution ends up being a negative 4. Now, let's talk about why that's a solution. I'm going to write something up here, and I want you to type it in the calculator. But let me finish writing it. Okay, see how all I've done? See how all I've done is rewritten that quadratic trinomial, but in the x places, I plugged in our first solution of negative 4. Go ahead and type that in and see what you get. 0. Well, doesn't that make sense? Because it says it'll equal 0. So that means that is one of the solutions. Now let's finish out this one. To finish out this one, what would we do? Add 1. So what's our second solution? 1. So let's check that by plugging it into the x places of the trinomial. Okay, go and type it in and see if it really equals 0. And it does. So we have just confirmed that we did the problem correctly because our two solutions that we got both cause it to equal 0. Now, let me show you a third way to figure out if you're right. I've got to pull up the graphing calculator, so give me a minute. Okay, now we're going to graph it. Get to it. Okay, so clear out whatever's in there from last period and type it in. X squared plus 3x minus 4, and then you don't type in the equal 0 part when you're graphing it. How many times does it cross the x-axis? Twice. Where is this one crossing?
Negative 4.
Negative 4, and where is this one crossing?
1.
Weren't those our two solutions?
There was.
See how many different ways there are to figure out the answer? Now, the reason we have two solutions is because it's degree 2. The highest exponent will let you know how many solutions you're going to end up with. So in this next example, how many solutions are we going to end up with? 3, because it's degree 3, cubic. So let's go and factor it. How would we factor this one? Can we go straight to the bubble method?
Pull the 3x out.
Right, we can pull out a 3 and an x. Because 3 will come out of 3 1 time, it'll come out of 15 5 times, and 18 6 times. And then you can also pull out an x because all 3 terms have at least one x. Now, when you're pulling that out, it's called the GCF. And what operation are you doing? Division. So like I just said, 3 divided by 3 is 1. You just don't have to write it. If this had 3 x's and we pulled out 1, how many are left? X squared. Think about it. If there were 3, we pulled out 1, there's 2 left. Okay, now, negative 15 divided by 3 is negative 5. If there were 2 x's with that term, you pulled out 1, that leaves just 1 x. And then positive 18 divided by 3 is positive 6. It only had one x, and you factored it out. So now there's no x's remaining. So now you can see that we're on the right track because we've left a quadratic trinomial that can be factored using the bubble method. You just have to keep in mind that you have to continue bringing down the GCF. It's part of your answer. So now we're looking for two numbers that do what? Okay, so if you're multiplying to get a positive, what do you know about your signs? They have to be the same, right? Are they both positive or both negative? Both negative, so that they'll add up to a negative. Now what numbers will do this? 3 and 2. Okay? 5 and 1 won't work because the signs match. Had the signs been opposite, that would have worked. Okay, now, had the problem just said to factor, we'd be done. But it doesn't. It says solve. So you have to continue. And what that means is set the 3x to 0. Set the x minus 3 to 0 and the x minus 2 to 0. And you're going to solve all three of these separately. So to solve this one, what do I do? Divide by 3. And so x equals 0. So there's one of your three solutions. We know we're going to have 3 because it's cubed. Then your next one, add 3, so your second solution is positive 3. And then what's your third solution? Positive 2. Now, what these three numbers mean is when you plug them in, like if I plugged in a 0 right here, and right here, and typed it all in, it would equal 0. If I did that with the 3, it would equal 0. If I did that with the 2, it would equal 0. Let's graph it and see what happens. Three x cubed minus 15x squared plus 18x. Okay, we can see that it crossed the x-axis 3 times because it's cubic. It crossed it 0, 2, and 3. And doesn't that make sense because that's the solutions we got? Okay, so now let's try the next one. Okay, for this one, how can we start factoring it? Is that it? 3x squared can be pulled out because all of them have at least 2 x's. Okay, now we have to leave what's left. What's left if you pull 3x squared out of 3x to the 4th? So x squared. And then minus 6 divided by 3 is 2. If there were 3 x's and we pulled out 2, there's only 1. And then negative 24 divided by 3 is negative 8, and both of the x's were factored out. So now we can see that we can bubble method what's remaining by looking for two numbers that add up to negative 2, multiply to negative 8. Anytime you're multiplying to get a negative, what do you know about your signs? Opposite. To get a negative, you have to have one positive, one negative. What numbers will do this? Right, negative 4 and positive 2 will multiply to a negative 8, and when you add them, it'll be negative 2. Okay, so now we have to continue. We set the 3x squared to 0. We set the x plus 2 to 0, and the x minus 4 to 0. To solve these is pretty simple. You basically can do it in your head. When you solve this for x, you end up with x equals negative 2. When you solve this one for x, you end up with x equals 4. Okay, what about this one? What would you have to do? Divide by 3. So x squared equals 0. And you could, but really at this point, you just kind of need to realize that that means there's technically 2 x's that equal 0, right? So you can write x equals 0, x equals 0. What does that mean about the graph? It's going to have a bounce. That's a multiplicity of 2 at 0. So let's see what the graph looks like. right here at negative 2, which was one of our solutions. Over here at 4, which was our second one. And then look, there's a bounce right there at 0, which counts as 2 solutions for a total of 4. And the reason there's 4 is because it's quartic. Does that make sense? Okay, so basically what you should have realized here is if I ask you for the solutions of this problem, which way are you going to choose to find them? Just graph them. Okay, so like with number 1, if I say solve using the graphing calculator, all you have to do is go to the graphing calculator and graph x squared minus 7x plus 6. It's going to cross twice because it's quadratic. And where does it cross? 1 and 6. Those are its 2 solutions. And think about it. That's because had you taken time to factor it, it would have been x minus 1 and x minus 6 because those add up to negative 7 and they multiply to a positive 6. But then when you had solved them, they would have changed signs. Okay, so on your own, you're going to do the rest of this page. But for right now, we need to go to the back. Okay, so this will be on your own time. Okay. I'm going to do 2 more with you. Okay, when you look at this problem, do you think you can factor that? Right, it's not a trinomial, it's a polynomial with 4 terms, and there's no GCF. So if I ask you to find the solutions, what's your only option?
Graph that.
Graph them. Okay, so let's go ahead and graph it. So let's see, it's 2x cubed. Oops, I forgot to erase it. Plus 11x squared. Plus 17x plus 6. Okay, how many times is it going to cross? 3, because it's cubic. And, well, no, there's no bounce because it's not, I know that it has a hump, but it's not bouncing off the x-axis. Okay, so look, where does this one cross? Where does this one cross? What about this one? It's about, right? So now you see why we weren't able to factor it? Because we didn't have nice whole numbers. So we know that we have one at negative 3 and negative 2, right? But to find our third one for sure, so we're not wrong, okay, is everybody paying attention? Hit second trace. And then aren't we looking for where it crosses the x-axis? 0. Isn't 0 another word for x-intercept? So we go to 0. Now, we've done something like this before. It says left bound. So what I'm wanting to do is go to the left side of this 0. So I'm going to move my cursor until I'm on the left side of it. Am I on the left side of it now? Yeah. Yes, so I'm going to enter. Then I'm going to move my cursor until I'm on the right side of it. Am I on the right side of it now? Yes. So I hit enter. And then I hit enter once more, and I see that it's at 0.5. Right, negative 0.5. So those are your 3 solutions. And now we see why we couldn't factor it, because the solutions are not nice whole numbers. Okay, so now let's try this one. Y equals 6x cubed plus 17x squared plus 6x minus 8. Okay, how many times does it cross? 3, right here, and right here. Are any of them whole number intercepts? No, look, that doesn't cross a negative 1. It crosses a teeny bit to the left of it. So we're going to have to use second trace to find this one and this one. But for this one over here, where does it cross? -2? Okay, so the other two cross at decimal places. So we're going to have to use second trace for both of those. So second trace, 0. And then let's start by finding this one. Okay, am I on the left side of it right now? I mean, that thing blinking, is it to the left of the intersection I'm trying to find?
No.
Yes. It's below it, but it's also a little bit to the left of it. So hit enter, and then move your cursor until you're on the right side of it and hit enter.
And then just press it.
And then hit enter one more time. And so where is that one located? 0.5. So now we only have one other one to find. Okay, we got to find this one right here. So I have to hit second trace, 0. I have to move my cursor till I'm on the left side of the location I'm trying to find. So, hold on, I went too far. About there would be fine because I'm definitely to the left of it. Shh. Now I have to move to the right side of it. And then once I've done both and it says guess, I hit enter one last time. And it lets me know that that intersection, or that 0, is at -1.33. Okay, so the front of this worksheet, you'll just graph them and they'll all be nice whole number intercepts. The back, you'll have to use second trace, 0. Okay, so at some point